And welcome to, let's hope, first of a couple of successful series. Today, I would like to welcome you all to our first Tech Talk, where we took the initiative in the Benelux to invite customers to talk about topics what we do believe are relevant topics. And today we are very pleased to kick off with our first Tech Talk and to have one of our valued customers here hosting this webinar, being Telnet. My name is Danny Mingelings. I am account manager within Checkpoint for telco, ISP, MSPs, and automotive. And what we are going to talk about is a topic what I do believe is a very relevant topic nowadays. It's about journey to the hybrid cloud. And the whole idea is, what does it mean in real life? And therefore, we are very happy that we will have Frederik Suys, who will talk to you about, who will take you with him to the journey to the hybrid cloud. Before we kick off, some housekeeping rules. Everybody is muted. If you do have any questions, there is a panel available. There is a chat available. You can ask your questions. That will allow us also to respect the timing that we have foreseen. And at the end of the session, we will have time for questions and even if you want an interactive discussion. But we really do not want to have other people who have other stuff in their agenda to, let's say, to miss some important stuff. So like I said, we're going to talk about the journey to the hybrid cloud. And when it comes to Checkpoint, as you all know, Checkpoint, we have a set of solutions that we have all brought together under umbrella, a brand, it's called Checkpoint Cloud. And what we do believe is when you make the journey to the cloud, it is very important that you do it with confidence. And with confidence meaning, we do not want, when it comes to security, we do not want you to overcome any hurdles. We want you to have a platform that provides you native security, but also gives you all the advanced threat prevention, as you know about, as you are familiar with Checkpoint, not only on all the cloud environments, but also on all your assets, on all your workloads. We want to have this everywhere. In a multi-cloud environment, hybrid cloud environment, private cloud environment, doesn't matter. But what is very important is that those set of tools give you a unified security and it automates your security. So the whole bottom message, and that's all I'm gonna say about this, we are not gonna dive into any products, but we do have a set of products available that in fact allow you to implement security by design during your cloud journey so that you do not have to take any hurdles, so that security in the cloud will not be the blocking factor. And I'm very pleased now to introduce you to Frederik Suys. Welcome, Frederik. Good morning.
Hello. First of all, good morning, everyone. First, I would like to, of course, thank Checkpoint for having me. It was a very nice surprise a couple of months ago when they asked me, hey, let's do something together. And so here I am. So who am I? I have about 15 years of experience in IT. In a very broad spectrum. I've been a software engineer, a test engineer, doing regression testing on Alcatel-Lucent service routers. And since the last 5-7 years, I've been mainly involved in data center networking. I've worked in a couple of different verticals, pharmaceutical, logistics, and now obviously at Telnet. And I would say my main, at the core, I'm a data center network engineer, right? I've been working with Cisco ACI a lot the last 5 years, and I think I can say I'm very experienced at it. But aside from that, I like to dabble in all new kinds of technologies. So I'm also a big fan of automation, Terraform, Ansible, those kinds of stuff. I have quite a lot of experience in Infoblox, or everything which comes with Infoblox. And since lately, I'm also heavily looking into public cloud because this is obviously the future. Right? You can also check my LinkedIn. There the full list is. And before we head off, I just want to give you a bit of a picture. Checkpoint and Telnet. So how is that relation? Obviously, Telnet is a big company, and probably some of you know Checkpoint from Telnet Business, right? Telnet Business is a business unit within Telnet who does B2B services for SMEs. And they have a very wide portfolio going from security, communication, telephone lines, whatever you name it. And a small part of that is security. And as far as I know, they are one of Belgium's premium support partners for Checkpoint. And so internally, I'm completely not part of that business unit. I'm in a totally different business unit, which is the TNI business unit. And what we do is we deliver IT, IaaS, and PaaS services on our own private and hybrid cloud of the internal Telnet infrastructure. And we are using primarily Checkpoint in our internal data center. And I think I can say we do use quite some advanced Checkpoint features. Like, for example, in our data center, Cisco ACI, we are at the moment we're speaking, we are completely transforming into a PBR design with Checkpoint, also using dynamic data center objects out of ACI. And what the topic will be of today is we have a hub spoke design with auto scaling both in Azure and AWS, and it's completely up and running. They can all talk to each other. So this is a bit short. What is Checkpoint within Telnet? And so today I will try to tell you a tale about my experiences during the last 1.5 years, about my journey. And I'll try to do that by describing 5 roles I had to take up to, and it is the role of the architect. I had to be an interpreter, a locksmith, a building contractor, and an automator. And further in the presentation, we'll dive deeper to it, but you can take this as a handles to see where we are in the journey, right? And before that, I want to start off with a typical use case, right? So about 1.5 years ago, we had got a request from a business party. They gave us, yes, we would like to set up a VPN. Here are all the details, all encryption schemes, primary, the shared secret, everything was there, filled in the template. It was like the engineer's dream, right? You know, a VPN is always troublesome to set up, but they did their homework, and these are the settings. Can you please set up this VPN? And we obviously, oh, wow, very nice. Let's give this to our MSP, right? They can do it. This is a job for them. So a week later, MSP comes back to us like, hey, but it doesn't work. Could you have a look, Frederick? Because we can't figure it out. Okay, so probably the VPN is up. I'm checking. Established. Everything is fine. Rekeying. Everything looks fine. So no, I can't find anything. So let's dig a bit deeper, right? And so, what are you actually trying to do? Yeah, we're trying to resolve this host name, and it doesn't work. We can't connect to that host name. So okay. So indeed. So after some investigation, but you're trying to resolve a host name, which is hosted on our internal DNS server, and you're pointing that to the public DNS server, and obviously that host name is not known there. So but we can fix that, right? Just point your DNS forwarder to the Telnet internal DNS server, set up some firewall rules, and right, okay, so DNS is solved, right? Okay, fine. Next step. Still doesn't work, obviously. So then I started to scratch my head, and it's a bit like, but what are you actually trying to do, right? What can you give me some more context? Can you give me a high-level design? What application are you trying to run on the other side of the VPN? We have deployed our application in AWS, and we're now trying to set up the VPN, and we're trying this, right? Okay, so it's on AWS, and so what IP addresses are you using there? We're just using the default IP address given to us by the AWS, and it doesn't work. okay, but what is this IP address range? Yeah, it's the typical RFC 1918. Yeah, but you do realize there's an IP overlap, right? So we need to think of some nothing or, oh, really? And then it starts to dwell in, right? It's like, wait, this will never work, right? Because they assumed they can connect, but obviously this will not work if there is an IP overlap. And then even a step further, it's like, yeah, but how are you accessing these resources now? Because it's already up and running and you just need one more connection to the internal network, right? Oh, yeah, well, we're just accessing it over the public IP addresses. And what security are you using there? Oh, no, I don't know. We're not aware of security. We just connect to the public IP addresses. And then it's like, okay, wait, let's take a step back, right? We need to take this to another level. We need to just stop doing whatever you're doing and let's do this in an enterprise way, right? Instead of being, it's all agile and fun and fast, but yeah, you have to think in a more enterprise way, right? And so this is a bit of an introduction. I hope some of you can relate to this kind of questions and this kind of things. And this was not a standalone case, right? There were like a couple of different use cases, but all coming to the same idea. And it is like there is completely no architecture or design for public cloud deployed applications, and it doesn't align with the internal network. So the first role is start with a design, right? We have to start with a high-level design just to make it fit in a network engineer's brain. So, and for this, Checkpoint helped me a lot because they have their higher level view, and it's called the Checkpoint Secure Cloud Blueprint. So this is, you can see there are two important links here. They first talk about a very high level introduction and then some more high level architecture and solutions, but it basically comes down to the hub spoke design, right? This is for network engineers, it's very straightforward. It's something we've known for years, and you can think of it as the hub is your central router, and every spoke is like a VLAN or a switch or whatever. This is a very simple and core design, in my opinion, for a network engineer. It's very logical. And what I do like about the Checkpoint way of presenting this to you is it's completely vendor agnostic, right? You could put any firewall or security vendor in place where they position it, and it still applies. And I think this is very transparent, and I like this, right? It's very well explained. It's very good from Checkpoint. And just to go a bit more and to put some more components, this is exactly the same representation, but what is the basic idea of this? Our Checkpoint tweaked it a little bit. It's like they separated in a north hub and the south hub. And what is the idea? All incoming traffic coming from internet enters your private cloud or your hybrid cloud, whatever you want to call it, through the north hub. And all the east-west communication, which means between spokes, or from a spoke to your on-prem, or from a spoke outgoing towards the internet, goes over your south hub. So I would like to call this more like the east-west south hub and the north hub to make a real separation. And what is nice about this is a very clear separation from incoming traffic, which is probably more, has probably different requirements from a security perspective than east-west or internal traffic or outgoing traffic. So, for example, in our case, we prefer to have the north hub. There we need the full-blown layer 7 application firewall, the complete Santa Boutique of options in our security gateways. We have deployed in the north hub, right? IPS, IDS, whatever you name it. In our south hub, we can be more easy on that, right? Maybe we only need layer 4 firewall filtering on the ports for certain hubs, maybe what you can do is between some spokes, we allow all communication. So it gives you a very flexible design, and you can pick and choose a bit what policies you want to apply where. You could even technically, or from a high level perspective, extend this design and maybe have 2 north hubs or multiple south hubs. So you can really be very flexible in this design. And so this gives us a high level design to play with. So this was something I learned during my journey. This is something we really need, right? Just some coat hanger to start with. Then something next was I struggled a lot with is like the language of the public cloud, right? Well, AWS, Azure, they throw all these terms at you: VPC, virtual network, what the VPC subnet, transit gateway, security rules. It's a completely different world from a linguistics perspective. But what helped a lot from me, and I have a strong background in ACI, so I will warn you, it might be not applicable for all of you, but what helped me a lot was some slides that I stole from Cisco Live presentations, the mapping of between the policy of ACI towards the public cloud objects. And once I saw these slides, it became very easy for me because I'm so familiar with ACI. I could easily translate, oh, security group, oh, you can translate this to an EPG, or an EC2 instance. This is an endpoint in ACI. The same goes for Azure. It's basically the exact same thing. Virtual network, this is a VRF, or the it's an EPG. So for me, this helped a lot. Maybe it's not applicable for everyone, but I'm sure if you're an ACI network engineer, it will be very easy for you if you know these translations. So an important step is learn some of the linguistics so you know what you're talking about, right? Because basically you still have to do network engineering, but instead of VLAN or router, they just use different names. But essentially it comes down to the same thing as you were doing on-prem all before. So we have our design, we know what we're talking about. Let's build this front and back door, right? Now we're becoming the locksmith, and let's really build this security domain. How do we do that? In Azure, it's very simple actually. There is an ARN template in Azure, which will build you either a scale set or a more simple active standby deployment. You can just go to the Azure portal, search for CloudGuard or for checkpoints. You will find this. Click the create button, and a couple of steps later, what do you get? You get, I hope you recognize a bit of the design here. So this is the internet. Then we have the in this case, so this is one hub. In this case, it could be, for example, the North hub, where we have the gateways, and we have our spokes in the backend. So to get a bit more in detail, we'll see later, but it's very simple. You click create and fill in some templates like IP addresses and load balancer IP addresses, and 5 to 10 minutes later, it's completely deployed in Azure. In AWS, it's exactly the same. You see here, again, in Azure, it's called ARN template. In AWS, they call it CloudFormation. But basically, it's the same thing. It's a template, and I'll quickly show it to you. So you have to fill in a whole number of parameters, like what's your VPC, what are some of your subnets you can select, some more checkpoint-related parameters, like what is your what license do you want to use? What shell do you want to start with? What is your SIG key? Some very basic things. Then you will click the create stack, and your gateway will be deployed. And in Azure, it's a different representation, but it basically comes down to the same thing, right? So this is your hub, where your checkpoint gateways are. These are your spokes, and you need to have some communication back and forth between them. So the gateways are built, but what's the next step? An important step is you need to do some configuration on your management server, right? What do you need to do? The management server actually communicates with the public cloud to find out all these details which you deployed in the public cloud. And so how do you do that? You have to use some command on the checkpoint management server, and you have to define what is my public cloud environment. So first you have to define some controllers. For example, your AWS account you can see here, and your Azure account. Obviously, I blanked out some of the proprietary details here, but this is how you can connect from your management server to the public cloud. Basically, it just comes down to provide some credentials, right? Another important part of this configuration is once you're connected, you need to apply some kind of template on the gateway deployed there, right? Because it's more or less an empty gateway. It doesn't do anything. You have to deploy a template. And in that template, you define what is the policy I want to install. For example, in this case, it's the AWS East-West policy. What are some of the blades I want to activate? So for example, identity awareness, I need it. So you define it here. And some custom options, like a custom script you want to deploy, some specific VPN community, what is the version, all these kinds of stuff you define in the template. And so the autoprof config, it's a very important part of the setup. And Checkpoint calls this the cloud management extension. You can find different SKs on it. And I'll show you a bit more detail what it does. It's actually a script. It's a loop going every 30 seconds by default. You see here, we're already at iteration 18,000. And what does it do? It checks locally what gateways do I already know. The management server knows these gateways. Then it will query what gateways are known in Azure and are they in sync with what I know locally. And we can see here it's up to date and the state is complete. And it will also do exactly the same for what are the gateways found in the public cloud of AWS. These are the gateways in the public cloud. What are the gateways on-prem? They're up to date and everything is fine. Obviously, this is in a already deployed environment, you see, but you would see if it's a new deployment, you will see found a new gateway, installing policy. You will see a lot more log. But I just wanted to show you it's a script. It's constantly checking the public cloud, and it will deploy depending on your templates defined before all this configuration on these new firewalls. Right? What is the last step before you have a up and running firewall? I would say it's define your security policy, right? You still have to do, once it's deployed, do basic security engineering, which is a security policy. In this case, it's obviously a very stupid, simple security policy. It allows all private or east-west communication between RFC 1918 and all outgoing communication towards the internet, and all the others I drop, right? It's the simplest policy ever, but this is what you usually start with just to see if everything is working, right? But don't forget HiNet, right? And I'll give you a bit more insight. Why do we need HiNet? This is not always required, but in our case, it is. So why do we need this NAT policy? And I'll come back there. I told you I will come back to this slide, give it a bit more detail. So you see, in this case, we have a virtual machine scale set. What is this? This is a construct in Azure, which allows you to scale out horizontally. So this means, in this case, there are two gateways drawn here, but for example, if your load arises during holiday season or whatever, they always try to sell it to you in this way. It would be possible you want to scale out to a third or a fourth or whatever number of gateways. Because you want to do that, you need obviously to be able to distribute the load across the different gateways. So you need a load balancer in front, and obviously for the return traffic, a load balancer on the other side, or vice versa, depending on obviously where your traffic is originating from. But the fact that you're using a load balancer to steer the traffic over a certain gateway, when the traffic leaves this gateway towards its destination, so if you follow this path, at the point in time when you cross the gateway, obviously you have to do some source hide nothing to be sure you can achieve a symmetric return path. Because in the case of a scale set, or in AWS, it's the same idea. The sessions between the different firewalls, they are not in sync. And so every firewall has a different session table. So to make sure you have symmetric traffic, you need to do source hide. And we might go more into detail, but this is the basic idea, right? So we have to install a NAT policy, and again, a very simple NAT policy here. So for all east-west communication on RFC 1918, we install a hide NAT behind this local gateway internal, which is a special object, and towards the internet, local gateway external. So how Checkpoint helps you in achieving this, because it's a bit tricky, right? How can you define in your policy to hide NAT behind which IP address, right? Because it's different for every firewall. Well, in this case, Checkpoint can help you by using a dynamic object. And what it does is the local gateway internal and external, they are actually translated on each respective firewall to its internal and external IP address, as shown here. So it's very easy from an administrator's perspective, because you don't have to take into account what are the actual IP addresses of these gateways. No, you don't care. And if there would be a scale out event, you don't even know, right? It's a random IP address given, obviously within the subnet defined, but it's given to you by the public cloud provider. And so Checkpoint helps you in using this dynamic object, which automatically translates it into the real IP address. Okay, so summary. We have our template to deploy the gateway. We have our constructs we have to define on the management server. We've built our policy. We're done, right? We've built a firewall, a security device in the public cloud, but we still have an empty box, right? It's a firewall, it's there, but there's no traffic going over it, right? And this is a bit where I'd like to make a difference between public cloud and hybrid cloud, because for me, when starting with these deployments, I deployed everything in the public cloud, right? I set up a new management server next to the gateways in the same VPC or subnet to keep it easy, right? And it's very easy to deploy this, and then you can connect a spoke, but probably in the same account or in the same administrative domain, and that all works. But this is public cloud, and as long as you stay in the public cloud with all of your components, it's at least easier than the next step, right? And what is the next step? It's like, yeah, you need to connect it to your on-prem now, and you need to connect spokes to it. And this was for me a big difference between the good and nice story you always see in the presentations, but in the real case, the network engineer still has to do it in the strict sense of the word, do networking, which means connecting different things together, right? And that brought me to my next hat I had to put up, and it's like putting this all together, right? As the building contractor, it's really bringing everything together. So first, we have to connect the spokes, right? And conceptually, this is very easy, right? Just take a step back, high level. What do we need to do? We just have to force all the traffic within a spoke who wants to leave this spoke to force it through this hub. And that's very easy conceptually, right? How do we do this in Azure? It is easy in Azure. You just install a UDR, which is a user-defined route, and you can compare this to a static route in classical networking. You just point it to the internal load balancer of your east-west-south hub, right? This one. It's easy. In AWS, it is damn hard, right? UDR, this concept, it doesn't exist in AWS. Some more details here. The ELB, so the load balancer in AWS, it doesn't support any ports. So this would mean for every flow going out, on any possible port, you would need to define a specific ELB configuration, which is completely not scalable. And VPC peering, so peering, for example, between different spokes, it's not possible. It's not transitive. It's very technical, and we can talk about it later. But these are some of the constraints, hard constraints by AWS, which makes it much harder. Of course, there's a solution in AWS which was released somewhere end of 2018, and it's called Transit Gateway. So it's a very technical solution, but it basically uses VPNs between the Transit Gateway router and every gateway, and over those different VPNs, you run BGP with ECMP on top. Right? It's a very technical solution, but it works. And this is, if you would need to configure this completely yourself, it will be very, very tricky because it's VPN, BGP. Oh, it's yeah. It might be interesting for a network engineer, but this is it's not what you're trying to do, right? Make it more complex. So Checkpoint can help you a lot in this because it completely hides this complexity for you, and it's all automated by the script which I showed you before between the management server and the public cloud. So the public cloud detects, this is AWS. Sorry, the management server detects it's AWS. It's auto scaling group. I need to configure some VPNs. I will deploy these VPNs for you, run BGP on top of it. So it completely hides all this complexity for you. And this is a very nice thing, right? Because it is very complex, I can assure you. So we've connected our spokes. What is the next step? We want to connect our on-prem, obviously, right? And in our case, we chose to use not a simple VPN, but a more advanced express route, for example. And in Azure, it's pretty easy. It's just connect your express route circuit to your hub virtual network, set up some routing constructs, and it works. In AWS, you have to attach your direct connect to the transit gateway, and basically they are more or less the same, right? You just set up a BGP between that public cloud router and your on-prem router. You can run BFD on top of it. And this is something, these high-speed connections, express route or direct connect, this is something Telnet Business could help you with setting it up. And internally, we are still a customer of Telnet Business, so we worked with them to set this up for us. And so today we have a 1 gig connection towards both AWS and Azure, specifically for this project. So some point I want to touch is if you connect your on-prem, you need to think of how do you want to treat your on-prem, right? Do you treat your on-prem as a spoke or not? And you can play with it both in Azure and AWS with the route tables, or with the propagation association of your transit gateway route tables. You can play with it, but you really need to know what you're doing. And in our case, we chose for our on-prem to be treated exactly the same as a spoke. So that means all east-west communication from on-prem to a spoke will be sent through the firewall and vice versa. You could deviate from this. For some spokes, you could choose, I want this spoke, for example, the hub itself, you cannot send the traffic distant towards the hub through the hub itself. So this is an exception already. But for example, you could have like a specific services network or with your DNS or whatever, some logging servers, where you don't necessarily want to send through the firewall. That's possible. So it is possible, but it just makes your design a bit more complex. So if we bring this all together, and don't stare yourselves blind on this slide, but this is more or less our complete high-level design in Azure. We have our north hub and our southwest hub and our spokes, right? So here are the north hub, the south hub, and our spokes. Then we use auto-scaling gateways, both in the north hub and in the south hub. So they're both auto-scaling gateways. We use a high-speed, low-latency private link, so in our case, express route, and we have our on-prem management server. So this is bringing all these things together. And in Azure, the networking part of it, it's more or less easy. It works if, obviously, if you know what you're doing, right? You need to learn some of the basics, but I didn't run into any showstoppers, let's say. And apart from, I'm just focusing on the networking part here. It works. In AWS, networking, it's really a pita. It can be very, very complex. At least this is my experience. For example, the on-prem management, because we are using those VPNs, the on-prem management becomes, by default, it sits behind the VPN tunnels. And this is something that the gateways don't like. They don't like to be managed by a management server over the VPN they're terminating themselves. So this is a bit of a chicken and egg problem, which is understandable, but that doesn't work, right? You have to do the route table management in AWS can get very complex. There are route tables on your VPC, route tables for your transit gateway attachments. You really have to pay big attention there. And another very technical detail is because of the HideNet, you use the tunnel addresses to HideNet behind instead of the native network interfaces, which really causes a problem. And there's a blog post I wrote about this, which you can find in the references later. But it's quite a complex issue, and you can solve this. But this was a roadblock for me, and luckily I have some good contacts with Checkpoint guys, and I immediately called Geert, and he was so nice to set me up with an expert on this within Checkpoint, and we figured this out together, right? And this is something very, very nice. So we've brought everything together, and we've built it. Let's destroy it again, right? I told you I'm a big fan of automation, and in my opinion, this is something every company should look at. It's very important to be, and certainly in these cloud native environments, you should be able to build it, destroy it, and rinse and repeat constantly, right? So in my case, infrastructure as a code is golden for me, right? And Terraform is excellent for this. This is a very nice tool. And why do I like it so much? Because it uses true idempotency, right? Ansible claims to be idempotent, but it really depends on your models. In Terraform, every model is truly idempotent. And what does this mean is, why do I think this is? It's because the state you deploy, so once you deploy something using Terraform, the state itself, whatever is deployed, it becomes part of your code. So your code knows, without questioning whatever is deployed, it knows what is deployed. And this is something unique to Terraform, I guess. You can use repeatable infrastructure. And what I mean with this is exactly what I told you before, is destroy and deploy it again, right? In my case, for every hub, for sure, I deploy this over 10, maybe 20 times, just by learning more and made a typo in the naming convention somewhere, or changed some of the subnets somewhere. My idea was, instead of going into the CLI or the web GUI and change it, no, I will just completely destroy everything and rebuild it. And it takes about 10 minutes. So just destroy it, build it, grab a coffee, and when you're back, it's there. And another nice thing is it uses declarative config, right? And you can see it here. If I want to deploy a new spoke, it's about 20 lines of code for me now. And what it does, you just have to provide some simple parameters like a common name, what is the name, some address prefix, maybe some password, some your credentials for your account, right? And this is very important, obviously. And in the back, everything will be deployed for you. The spoke, the attachments, the connections between all of them, the firewalls, the firewall, possibly even firewall rules for this specific spoke. Everything will be deployed for you, instead of doing everything in the GUI, right? And part of it, as I showed you before, was there are, of course, the ARN templates in Azure or the CloudFormation, but this only deploys your gateway, right? It doesn't deploy your network, which is the end-to-end flow. So the things I wrote was, it deploys my express route, it deploys my hub network, it deploys my spoke network, the connections between them, and on top of that, it deploys the firewall. So deploying the firewall is just a small part of the complete overall solution. And this is, in my, at least Terraform helped me a lot in this. Of course, there are some alternative automation options. You can use the native CLIs of public cloud environments, PowerShell, Ansible, whatever you name it. I would just think of automation, right? It is, if anything, you take with you, think about automation when you start in your journey. Something else I want to mention here is the power of dynamic objects. And if you're going to the public cloud, you need to think of, you need to step away from your legacy mindset, which is tying your security as an the identity of your security should not be more your IP address, right? In the past, it was the IP address. Now you can use dynamic objects. For example, you can reference a spoke resource group, right? So in this case, I wanted to allow communication between a spoke in Azure and spoke number 1 in AWS. And I don't use IP addresses, right? I use an object, some kind of dynamic object. And what it does, it translates this object. Once installed on the gateway, it will translate this, in this case, to 10.10.238.128/27. But if I would change this subnet, it would dynamically be updated in my policy. Same for the other side. So in this case, it's towards AWS. So you see, in this AWS account, it translates to this subnet range. So in this example, I took a very basic, so spoke to spoke, but you can go crazy with this. You can use labels like web2db, you can use security groups, more or less any kind of label which is provided by the public cloud. You can hook up your management server to it, and it can read dynamically, yeah, but what does this label effectively represent? And of course, in the end, it will be programmed in your gateway as IP addresses, but it's dynamic, right? If the reference changes, the IP addresses programmed will also be updated. And this is something, especially for the public cloud, I would strongly recommend. And also now for our on-prem cloud, we are also looking into this. So this, they lived happily ever after. So after I put on the hat of all of these different roles, I think I managed to deploy an end-to-end hybrid cloud solution using Checkpoint. So some of the key takeaways, I would say, is start with a high-level design, right? This is your basics. Don't just start with deploying and then see, oh, okay, it doesn't fit in my overall design. No, use a high-level design. Learn some of the basic terminology of AWS and Azure. Just play with it in a sandbox. Use some very simple, just know what you're talking about. Azure, start with Azure. It's easy. And if you want a challenge, start with AWS. Get your hands dirty, right? Do it over and over again, destroy it, try it again, try some different tweaks and turn some knobs, and preferably do this using automation. Something which is I would strongly recommend is deploy a troubleshoot fee. I mean, every network or hub or spoke, whatever you want to name it, so you always have access to it, because often I cut off my own leg, all right? And luckily then I have a public interface which I can connect to. Obviously only do this during deployment, right? Don't do this in a production environment, but have a troubleshoot fee, and so you can check what's going wrong. Don't underestimate this complexity, right? So they always tell you, yeah, public cloud, it's so easy and it's very fast. Yeah, but still it's complex, right? Once you start bringing all these things together, you really have to know what you're doing. And it sounds easy on paper, but once you start combining all these things, you really have to, know your stuff. And maybe the last one, maybe this is the most important one, is talk to another human being, right? Telnet Business and Checkpoint, they are ready to give you this support. And this was what for me helped me the most, is like just talking to Geert and discussing with him, because they have the experience and they can guide you to the right path, right? Usually when I was stuck, I called Geert or sent him an email. A couple of days later, we had a session, and I could continue, right? Don't get stuck on yourself, but talk to people, and together we'll get there. So I think we're coming to the end of my presentation. So I guess it's time to unmute and start grilling me with some questions. But after the session, obviously feel free to talk to your Checkpoint account manager, talk to Telnet Business, or if you really have a very specific question, you can always drop me an email personally. Maybe I'll hand it over to Danny again, if you want some.
Thank you. Yep, thank you very much, Frederik. Thank you very much. And I hope this was very useful. At least I think it was very relevant, because I think it's a kind of journey that most of customers are going through. So there is now time for questions. So if anybody has questions, you can either use the Q&A section, or you can ask. I don't know if you can unmute yourself, but I can maybe, otherwise just raise your hand and then you can ask your questions.
Maybe Jeroen, can you retype it, because it's a bit confusing. There's a mix of Dutch and English. Who cast do?
I guess the question is, how do the dynamic objects pick up the IP address?
Yeah, okay.
That's what I read in it. If it's different,
well, as far as I know in detail, actually what happens is there is, in the background, every 30 seconds there is a poll by the Checkpoint Management Server, which which checks all the dynamic objects which are being referenced. It will call your public cloud provider for these objects. It will query, is there any change? Right? And if there is a change, it will notify the individual gateways, and through identity awareness, they will update this dynamic object in their own policy, and then at that point in time, the IP address will be updated. So it's every 30 seconds, if I'm correct.
Which is, by the way, a configurable parameter, if you like. So it's something that can be adapted, although I see that all of my customers leave it by default. 30 seconds is actually a good balance between not overloading your management server with a lot of information from different clouds, and still have the time, for example, for a virtual machine to spin up and have that new IP address of that machine being used in the access policies.